All right, Chapter 4 in Earth Science is on weathering soil and soil erosion. I'll be splitting this chapter into two pieces because this chapter is split on two different days of the schedule. All right, so this first video is going to take the slides on the different processes that can change uh, one rock to a different type. And this is essentially called weathering. This is the disintegration and decomposition of material at or near the surface of the earth. There's going to be some other things in this chapter I'm not going to cover, like mass wasting. I'm not going to be covering that topic, but it's still on this slide. So just know at least what its basic definition is. So this is the transfer of rock material downslope under the influence of gravity. So if you just think of a mountain, if stuff rolls down the mountain, and maybe if it's sediment, it could form a sedimentary rock. That would be a process called mass wasting. And then we have erosion. This is the incorporation and transportation of material by some agent, and this agent could be water, it could be wind, it could even be ice if we're talking about glaciers. So there's two types of weathering that we'll be talking about. This will be mechanical weathering. So this is the physical breaking of rocks into smaller pieces. And then finally chemical weathering, where there's going to be some type of chemical agent, typically an acid, that can break down a material and then precipitate out a solution to form a different type of rock. All right, so what happens with weathering is you increase the surface area when you mechanically weather something. So just like in a chemical reaction, if you have a larger surface area in contact with the chemical agent or chemical catalyst, the reaction speeds up. The same thing happens with mechanical weathering. So if you had this, let's say this square piece of rock over here on the left, you only have a certain amount of surface area. When you break that piece apart into, let's say, 8 smaller pieces, you're increasing the amount of surface area that can now be weathered. So it just increases exponentially as you break these pieces apart. So mechanical weathering becomes easier as you break the pieces of rock into smaller and smaller pieces because more surface area is being exposed to the process. So there are 4 important processes that we're going to talk about for mechanical weathering. One is frost wedging, and this is essentially when water freezes, it actually increases its volume, which is atypical for liquids. Typically when you freeze something, the volume decreases. I'll give you an example. If you were to fill your car up with gas on a hot summer day, but you did it in the morning when it was cooler, if you filled your gas tank up, and then later in the day you may see actually gas coming out of your car. That's because the hot air from it being a hot summer day would actually increase the volume of the gas as you went into a higher temperature. So water does the opposite. As you freeze it, as it gets colder, its volume actually increases. So in northeastern PA and probably a lot of other regions, north of Pennsylvania, we have a big pothole problem. So essentially what happens is water seeps in underneath the streets. It then freezes, and that freezing expands the water and creates a breaking apart of rocks, which is essentially what we're defining as mechanical weathering. Another example would be salt crystal growth. So if you've ever seen a geode before, that's a rock where on the inside you have different types of crystals forming. So when that happens underneath the ground, it actually breaks apart the rock because you have some liquids going inside of rocks, and it's creating crystals, which then breaks apart some rocks. You also have sheeting, which is you're generating these layers and exfoliation domes underground. I won't talk about that too much. And then you also have some biological activity, which can cause some mechanical weathering. So frost wedging, so it's basically a pothole on a very large scale. So in this picture, you have a mountainside that's basically being broken apart because you have water going into the rock. It's creating ice in the voids, and then when that water freezes into ice, it expands and then it pushes the rock pieces apart, and eventually you have rocks falling down the mountainside, which is essentially mass wasting in this case, but the actual breaking apart of the rock would be considered frost wedging. So sheeting and exfoliation. So let's say you had a really big piece of an igneous rock underground. So if you remember, igneous rock probably means that there's going to be some magma nearby. So that increase in temperature is going to make that piece of igneous rock push up through the ground, and that's going to break and spread apart the bedrock. So then you eventually have rocks protruding outside of the ground and then breaking apart and moving things around near the surface of the Earth. All right, chemical weathering. So again, this is going to actually be altering the internal structure of minerals by adding and removing elements. So we're actually going to be changing from one type to another with chemical weathering. Now, more importantly, for chemical weathering, you have to have some chemical agent that's doing this change. And typically that agent is water. So if you put water in basically anything, if it doesn't have a pH, which indicates the acidity of a substance, you know, natural water can sometimes be on the acidic side, so it can break down materials. So you could also have sometimes carbon dioxide dissolving in water to form a different type of acid. So that would be called carbonic acid, which could easily alter a material. It could change the actual elements inside of that mineral and changing it into something else. So there's also a weathering of granite. So this is when you weather potassium feldspar. It produces different types of clay minerals, and this is where you're going to have that salt crystal formation, which can actually change the actual chemical makeup of the substance. Another example will be quartz. As I mentioned, when you have a geode, it's typically sometimes the particles inside of the geode is a quartz-like material. There's also a type of chemical weathering called spheroidal weathering. So this will actually give you rounded edges on rocks. So sometimes if you would see a mountainside or different types of materials just laying about on the ground and you would see them very smooth and round, like it's probably due to spheroidal weathering.